All right, then we will go ahead and get started because I don't think anybody else is showing up, or if they do, it is what it is. So obviously me and you know each other, but for those in YouTube world, I'm Ryan Huffman. I'm the moderator for this wonderful breakout room. I'm here with the pleasant Greg Wilson, who is the Dean of Applied Technology. I'm here with the wonderful Steve Grede, who is the computer-aided design. And I'm here with Jay Deaver, who is the machining expert. And we have Colleen. Hello, Colleen. Welcome.
Oh, hey, how are you?
Doing well. We're just going through introductions right now. And I'm going to go ahead and pass the torch off to the fabulous Greg Wilson.
Thank you, Ryan. Welcome, Colleen. Welcome, Diana. We will kind of break it up. So I'll go first and just kind of give a really quick overview of applied technology. And Jessica is back, so that's good to see. And then I'll pass it off to Steve Grede, who is discipline coordinator for our computer-aided design program. And then he'll pass it to Jay Deaver, who is department head for machining. So I'm just going to quickly share my screen. And I'll go a lot faster this time because the 5 minutes does go quickly.
Yeah.
Can you see the purple screen okay?
Yes, sir.
All right. So quick overview of applied technology. We have multiple programs. In a normal semester, we serve about 1,200 to 1,300 students. And the average age of students in applied technology is close to 30 years old, which is slightly older than the 28-year-old average for the college overall. The programs that we cover in our area are automated industrial technology, which is the picture at the bottom. Giannina is working on, again, I think that's a hydraulics module. So our automated industrial technology program covers automation, which would include hydraulics, pneumatics, programmable logic controllers, and then we have a whole section on robotics. We also have an automotive technology program, which is where I am right now, in the brand new 50,000 square foot Automotive Technology and Innovation Center. We also have an aviation program. It's the only program in the division that is not at the downtown campus. They have a location by the airport. That is also undergoing an expansion. They are increasing their footprint from 35,000 square feet to about 80,000 square feet. That's possible because of a $15 million allocation from the state legislature, because we have a real dire need for aviation mechanics, and that expansion will allow us to double our output. We also have a building and construction program, which includes carpentry, electrical, HVAC, and plumbing. We also cover safety competencies and some management. I won't go into anything with CAD because Steve is here to represent the computer-aided design program. We also have energy technology, which is heavy industrial, electrical, and some pipe with Southwest Gas and TEP. Jay will cover machining, and last but not least, we also have a welding program that does a great job preparing students for the industry. Really quickly, just want to talk about centers of excellence because we are going through 4 stages of expansion. The first being the completion of the new automotive complex. Aviation would be second. That'll be done in April, early May. Stage 3 is going to be the brand new 3-story advanced manufacturing building. And then stage 4, when we move out of our current space, building and construction will move from about 2,500 to 3,000 square feet, and they will take over the 25,000 square foot building. But a center of excellence is more than just cool spaces and shiny equipment. It's about developing a comprehensive workforce that is skilled to meet the needs of industry and the community. We also partner with the K-12, the JTED system, and our high school partners, as well as the university. And we try to innovate as best we can. So that can take the form of a new automotive thing where we teach students how to calibrate advanced driver assist systems based on a white paper that just came out a couple of months ago. So our programs are very flexible and able to adapt to what industry needs. This is an example of a partnership we have with Caterpillar, where we train their engineers on machining, welding, and prototyping. So we kind of force them to learn how to deal with hands-on skill sets, something that a lot of them do not have. So when I talk about doing different things, that's an example. We also partner with Too Simple. Pima Community College offered the very first autonomous vehicle operator certificate, which was a joint program with the IT division, our division, as well as the workforce division, which is where the truck driver program is housed. And here's just a couple of quick pictures of our brand new building. And I'm going to switch because I know I only have 30 seconds. Steve, I hope you don't mind if I just steal a little bit of your time. I'll just play this video very quickly. We won't go through the whole thing, but just kind of want to share. Can you see the video as it's flying into downtown campus?
No, I'm still on your PowerPoint.
All right.
Techno fairies, gotta love them.
Here we go. So now you can kind of see we're kind of flowing into downtown campus. And I'll just kind of go a little faster. So this is a video of the 3-story, 100,000 square foot advanced manufacturing building. It's where our machining, welding, computer-aided design, and automation robotics programs will move. The building should be done about Thanksgiving. But there's a lot more to it than that. It's going to have a business incubator. It's going to have an idea lab on the first floor. We're going to have a big community space on the 3rd floor. All of our offices will be there. But it's basically a community hub where businesses can get started, students can interact with industry, with the university, faculty. It's going to be a gem and a, one of the prize locations throughout the state for advanced manufacturing. So I'll leave it there because I know I've gone over. And I will turn it over to Steve Grede, again, discipline coordinator for our computer-aided design program.
Thank you, Greg. So I'm going to share my screen, and I have a presentation that's going to highlight some of the careers and the certificates and degrees offered in computer-aided design. So computer-aided design is the use of computers to either draft or model, is used in a wide number of industries. The degrees, or the associate degrees that we offer, are Associate of Applied Science in computer-aided design, and we have 2 kind of specializations, or 2 branches that you would take, 2 pathways you would take. Mechanical, electromechanical concentration, that's more in the manufacturing area. Optics, design of vehicles, and certainly companies like Raytheon. Construction concentration, they have that's a wide range of architecture, landscape architecture, interior design, civil engineering, construction management. So any of these fields that really have to do more with the built environment rather than the manufactured environment. And there is a little bit of overlap between the 2. We offer quite a few certificates that all lead up to these AAS degrees. So in 2 semesters, you could have an entry-level certificate as a SolidWorks designer, CAD technician, or Revit technician. And then we have certificates that are more advanced that build upon that. All lead up, if students so wishes, to a AAS degree. So we're going to take a look at some of the student work for design and engineering. The primary software that we utilize there is SolidWorks, but we also do teach Creo. And so we have a couple student designs of systems. Not only do you model and prepare documents for the manufacture of this, but you utilize the software for analysis as well. So it's not just learning the software, we're learning how the software is utilized in industry. So one of the great advantages that we have, or opportunities that we have, is we have quite a bit of 3D printing machinery, so that we can also really work on manufacturing and rapid prototyping. And because we partner with Machine Tool, and Jay will be speaking to you about that shortly, we can also talk about some of the CNC programming and how these 2 degrees can overlap. So let's talk about the other pathway system. So we can have some architectural work. We have both residential and commercial coursework. In the software that we learn, we do work in AutoCAD, in Revit, in SketchUp, and some advanced Revit such as Revit MEP. So here's some examples of some student work with architectural. That was Revit. This is SketchUp. So I have a very short animation that can work with, this is a playhouse design that a student produced in the CAD 151 course. So we also prepare students for employment in civil engineering, and the software that we use there is Civil 3D. We have 2 courses in that, and we also teach ArcGIS as part of that, or for any of the coursework in the construction concentration.
1 minute.
Areas that we don't have necessarily specified coursework for, but a number of students take our certificates or degrees and work in these industries include interior design, landscape architecture. We have some coursework. We have 2 LTP courses to teach landscape design and also plant materials and planting design. And construction management. It's important in the world of construction management I have a great animation there, but I'm afraid that I may be out of time on that, is a great opportunity to understand the building systems, to take that building information modeling and to utilize it in the construction management process. So let me just go ahead and stop that. And I see that my time is up. So I think I'll be handing this over to, here's the information for a program advisor and our department head. So I think Jay, if I'm not mistaken, will be presenting next.
Correct. Thank you, Steve. And on to Jay.
Hi, I'm Jay Deaver. I'm the department head for machine tool technology, and we manufacture things. We start with a lot of the design work that comes out of the CAD department, the electromechanical side that Steve just described. We are largely a subtractive process. We start with solid blocks, bars, plates of metals, plastics, composites, a variety of materials, and we whittle it away until we have what the engineer intended as a finished product. The short version is, if it doesn't come out of the ground without the help of man, we had a hand in it some way. We make the molds for making your cell phones, the mouse for your computer, the soles of your shoes. We do a lot of the parts for your car, the parts for aircraft, etc. Our program is centered around an Associates of Applied Science. It's a 2-year degree. That typically is going to put people on a track for career development, direct employment. We offer 2 certificates. We offer a CNC operator certificate and an inspector certificate. These are immediate employment, less emphasis on the academic side, strictly technical skills to get you through that interview, to get you through that onto the shop floor, start making money in the trade, start getting experience. So our program is, we have a manual component and a CNC component. Manual machines are, this is all power machinery. We do hand-driven, hand-selected, manually operated equipment, and our CNC side is computerized, numerically controlled. So we're going to be using automation to cut and fabricate all of these parts that we make. Some of the skills that you're going to need to have, we teach in partnership with the CAD program. They do teach blueprint reading and our geometric dimensioning and tolerancing. Those are vital skills to survive in the industry, whether you're a designer or a fabricator or machinist. We also cover inspection and precision measurement. We have the science portion of our program is metallurgy, which is the science of how metals behave and how they work, how they operate. And that will be in our associate's degree. We utilize Mastercam for our CNC programming. Once we get to the automation component, we also teach manual programming, meaning you're going to learn how to read a blueprint and translate that into G&M code. You're going to learn how to set up these machines, how to operate them, how to adjust them, in short, you're going to learn how to fabricate parts on manual and robotic equipment. From engineering design, and we do work from 3D models in the Mastercam for the automated programming, but everything comes back to the blueprint. In modern manufacturing, the solid model is part of the blueprint. So we have a pretty wide skill set, and there is a bit of overlap between the CAD program and the machining program as far as skills. The CAM software, like Mastercam, that we teach here,
1 minute.
We certainly, like I said, we utilize the solid modeling technology. So you're going to need some of those CAD skills. So, like I said, we partner with the CAD department to facilitate that. Moving into the Center of Excellence, we are looking at adding robotics for robot loaders for the machines, going deeper into automation to service our local industry needs, and to make our students more marketable and more valuable to their employers. So I think I'm going to wrap up there, and I will hand this off to Ryan, I guess, again.
Thank you much. And then we have a short video to share with you about the aviation department. Let me make sure that I am optimized for video, and here we go. All right. And do we have any questions from Colleen or Diana for any of our wonderful subject matter experts?
Not at the moment. Thank you.
I don't have anything, thanks.
All right. Well, luckily I like to come prepared with a couple. So I'm going to go ahead and ask Greg, what's the best way to be successful in these types of classes or programs?
Oh, I'm definitely going to defer to Steve and Jay to answer that question.
Well, there we go.
They know better than I do.
So this is Steve Grede. I'm going to jump in. Can you repeat that? And I think I have an answer, but I want to make sure I'm answering it properly.
So what's the best way to be successful in these types of classes and programs?
The number one way that I find the students are successful is they form community, to be part of that learning community in that environment, to support one another all the way through the program, and then beyond. When somebody gets a great job and that company is hiring, by all means, let the company know that there are some other excellent people at Pima, and maybe they'll have a shot at employment there as well.
Jay, do you have anything that you'd like to add?
Be curious, be hungry, show up and want to learn. I mean, be that natural inquisitiveness. Like I said, these trades and these skills, CAD, machining, welding, aviation, automotive, they're all driven by STEM. It's all about science, technology, engineering, math. You just need to want to understand how things work, because we design how they work. We make them so that they work, from paper to planes taking off.
Thank you. All right, that pretty much is all the time we've got for today.